So let us continue our discussion from the previous class. So in today's class, let us discuss about the characteristics of IoT. Characteristics of IoT. Characteristics of Internet of Things. Let's keep a track on this.
You are not coming on the video.
So
Actually, board is only coming, sir. You are not coming in the video.
okay, I am not coming on the board. Like I am this. Later, fine. This is visible. Sometimes here and there, if I go out of the board, also no problem. Right, content should be visible. That whole frame of the board should be visible. I am audible to everyone? Yes. Right. So characteristics of IoT. The first characteristic is dynamic and self-adapting. Dynamic and self-adapting. What do you mean by this? Right. Here, dynamic means we understand the general meaning is right, changing. Keeps on changing. Right. So the point here is yes, it changes, but the system should adjust to the changes. The system should adjust to the changes. For example, right. So let us together understand and self-adapting. Adapting is what? Get adjusted to environment. Yes or no? Get adjusted to environment. Since 15-20 days, here we have chilling code. Are we adjusting to it? Yes, we are adjusting to it. So what we call? We call it as a adjusting to the environment, that is adapting. Right, so we have another meaning called as ADOPT, another word. That adapt is different. I think you understand, right? So this is adapting, ADAPT. So dynamic and self-adapting. Let us understand this example. We have tubelets here. All the tubelets say are connected to the internet or the part of the Internet of Things. Let us understand these are part of the Internet of Things. Now we have enough ambient light. Ambient light, you understand ambient light? The ambient light, the light that is coming from nature, right? That is when sun. We have ambient light. Now in the morning 6 o'clock there is no enough ambient light. As the sun rises, the ambient light is increasing. The intensity of the ambient light increases. In such scenarios we don't need tube lights. Yes or no? Then the tube lights should dim accordingly. The time the ambient light reaches maximum, we feel that ambient light is enough in this room, the tubeless should switch off automatically. The tubeless should switch off automatically. It is dynamic. Yes or no? Are you understanding this?
Yes, sir.
Now suddenly, say at 12 a.m., it is full cloudy. There is no enough ambient light. The students are sitting in the classroom are not able to read and write. The visibility is less. In such scenarios, again, say here, that's the right tube light. The tube light, right, the intensity should increase. The brightness of the tube light should increase. Tube light brightness should increase. This is about dynamic. This is about dynamic. We can have one more example of cameras, CCTV cameras. CCTV cameras. You can observe here under the CCTV cameras. During night time, the infrared light on the cameras switch on. I observed it. Right. There are LEDs, two LEDs. Right. It depends upon which camera it is. Right. There will be many LEDs. There will be two LEDs. Right. As the sunlight gets darker or in the night time, those LEDs switch on. You can observe, right? And you are moving here and there. It's dynamic. Now, what is self-adaptive? What is self-adaptive? Same context, same two grades, same classroom, same two grades. When I switch on this projector, I want to teach in PowerPoint presentation mode. I want to use the slides. As soon as I switch on this projector, these two grades should go off. Yes or no? These two grades should go off. This is the best example of self-adaptive. Every time when I come to the classroom, when I am teaching, there is no enough ambient light. The tubelight should switch on or increase the brightness. As soon as I switch on the projector, these tubelights should go on. Self-adaptive, according to the environment. Is this idea clear? Yes. Is this idea clear? So we are expecting this characteristics from our IoT system. From our IoT system. I also have given you a small project for you. You can do a project on this. At the end of the course, you can do a project on this. I will, right, during this course time, I will give you lot of solutions. Right. Only thing you have to implement it. You have to implement it. There are problems. We also discuss solutions, and you have to materialize it. In the sense, you have to take a code, you have to program it. Materialize, you understand, or implementing, executing, you understand. Yes or no?
Yes, sir.
Right. We should be aware. In this society, in this environment, we should be aware. Where are the possible? Where are the problems? Where are the problems? What IoT solution I can do? What IoT solution I can do? You can sell this product also. You can sell this product. Isn't it?
Yes, sir.
IoT solutions, you can open up them, you can have a startup. IoT solutions for home automation, for office automation. Right. Now, coming to the second characteristic. Self-configuring. Self-configuring. Configuring. What is the meaning of configuring? To keep it simple, configuring means arrangement. Configuring means arrangement. Whenever you come inside the class, you will occupy a place, you make the neighbors to slide this down, you will take out the books, means you are getting ready for the class. Here it is self-arrangement or self-configuring. Self means by itself, without the intervention of human beings. See, in today, right, approximately, there are estimations, if we see different sources, there are different estimations. By 2024, how many devices are connected to the internet? By 2025, how many will be there? Today we are like about to finish 2025. There is also an estimation by 2030, how many devices will be connected to the internet. Right. So let us say a number which is not accurate. Let us have a rough number. Right. Say nowadays they are saying 13 billion devices are connected to the internet. What is our world population? 8 billion is our world population. is population of the world. It is world population. That's it. 13 billion devices are connected to the internet. You are using your smartphones, your laptop. Sometimes software updates come. Yes or no? The antivirus that you have purchased want to scan your mobile phone. It depends upon your settings. It happens automatically. Right? There are options for you. Make it happen automatically or seek your permission. Seek your permission. Because you are using your mobile, you have only one mobile with you, fine, you can deal with it. When there are 13 billion devices, can we handle? No. Can we handle? No. They should be self-configurable. They should be self-configurable. Whenever there are any updates, the updates should happen automatically. Right. Whenever a new device is come into the system, suppose these two tablets, these four tablets are there already, which are Wi-Fi controlled. These are automatically controlled based on the environment. Sometimes I want to switch off and switch on it. Again, sometimes I think that this brightness is not enough. I will install one more tublet. I will install one more tublet. As soon as I install the tublet, I connect it to the electricity. The Wi-Fi system, your Wi-Fi in your room should automatically discover the tublet. Your Wi-Fi should automatically discover the new tublet. Discover new tublet. Whenever I install the new tublet, it should automatically discover the new tublet. Then this new tublet should automatically reveal its identity. See, I have a tublet. So and so specifications, it should be visible. And the connection should happen automatically. The connection should happen automatically. And whenever I see this in my mobile app, tublet 1, tublet 2, tublet new should be visible in your mobile phone. Yes, in my network, another tublet has been added. Now, if I want to, I can control this tublet manually also. I can control that tublet manually. This is how the self-configuration works. Or what does the self-configuration mean? The expression I have given is the question. Self-configuration. Is this idea clear? Right. Now, let us see the third characteristics. Third characteristic. Unique identity. Unique identity. Yes, you are understanding. Unique identity means it should have some unique number to it. For example, your student ID is unique. See, there may be 2 Tarun in this room. There may be 2 Shivakumar in this room. Right? There may be 2 Pavlis in this room. If I say Pavli, which Pavli there is a confusion? Yes or no? If I say Tarun, which Tarun is a confusion? Sai, there are many Sais. Most common name. Right? Sai Teja, Sai Kiran, Sai Varun, Sai Ganesh. Right? So, when I type Sai, which Sai? Hence, here, what we do in our university? We allocate a unique identity, that is student ID. Now, everybody has their own student ID. Your student ID is different, your student ID is different. It is unique. Now, it is your property. You are the only one person who will have that ID. That ID is not given to the other person now. Yes, sir. It is clear, sir. It is clear. But what is the reason typically? Why we are doing this in this Internet of Things? Why are we doing this? See, in today's internet, which is based on this TCP/IP, what is unique identity? IP address. Yes or no? Unique identity is the IP address. But the question here is why? Why the systems in Internet of Things should have unique identity, or in general, why a student in a university should have unique identity? Can anybody give me the reason? Yes? Try. Let us make the class interactive.
Easy for configuration. Easy for configuration.
Okay, very good. Easy for configuration. One answer. Okay.
Communication.
For communication purpose. Good. Now one more precise answer. Okay. To recognize something. Another answer. Some reasonable answer is coming. Yes, madam. To avoid collision. Yes. That is also a good answer. It is because when I want to communicate to you, I have to communicate to you only. Suppose I want to communicate to Dolendra. I have to communicate to Dolendra only. There should not be any confusion. When I receive some data from Dolendra, there should not be any confusion that I have received from other person. See, here it is very crucial because I am receiving the data of somebody's heart rate. A person is wearing a smartwatch, a health gadget, which is measuring his heart rate. Now I am recording this data, I am uploading it to the cloud. His family doctor want to access that data from the cloud in his mobile app in order to monitor his patient's health condition. Right. Now that doctor has 7-8 patients with him. Now in that scenario, each patient should have their unique ID. Yes or no? His patient X heart rate he is seeing, but because there is no unique identity, he may misread it as a patient Z's heart rate. The patient who is in the Nizamabad, his health condition is not good. There is a disturbance in his heart rate, but doctor misreads it that the patient is in Basra. This is a dangerous condition. Yes or no? Yes. Now, this tubelet I want to control in this room. I should have clear idea of this tubelet so that I can control this tubelet only. It is not I am controlling the tubelet of the other room. I have switched off the tubelet, but the tubelet in the other room has switched off. This should not happen. So here in Internet of Things, unique identity is also very important part. When we are discussing the protocols, we can discuss in detail which are the protocols, right? They are able to give unique identity to the devices in the IoT. I think third point is clear. Now let us look at the fourth characteristics. Integration into information network. the previous class we have seen that example, forest fire detection system. Today let us take an accident detection system. Let us see, right, to understand this integration of information, accident detection system. What does this mean? In a remote area, हम 30-40 kilometers from here, a vehicle, a car which is connected to the internet has suddenly occurred with accident. Has suddenly occurred with the accident. Should I need that information immediately? Yes, it is very important because to provide the ambulance service, I need that information as immediately, in real time. In real time. Real time. What do you mean by real time? I think I will derive your topic in this context. In the real time applications, when I won't attend it immediately, there is a loss of life and property. There is a loss of life and a valuable property. Real time applications. Right. So that car has accident. So the accident is happened. This is connected to the internet. It should send the data immediately, the accident data to the cloud. And from the cloud, an ambulance service in his mobile app, he should receive that data immediately, in real time. Right? And the same data should be able to access by an ambulance service. So ambulance service. Right. Something of that. So they can reach this place through this geolocation. What it should say? Which kind of data? Accident data? Geolocation data? So that these people can reach here as immediately as possible. There should not be, see now, what is the point? Integration into the information network. This total thing is the information network. This total thing is the information network. Now, I will say, in this, between these 2 points, if there is any disturbance, if there is no connection for time being, because due to many reasons, or if there is no information flow here, the whole purpose is better. Yes or no? Yes. I am doing accident detection system to save a life. If there is some information interruption here, no connection here, for some time, for some duration, if there is no connection here, for some time, some duration, then the whole purpose is better. Yes or no? This should not happen. This should not happen. So one of the one of the characteristics, all are important. Important characteristics of this, right? This integration into the information network. Whenever you are doing a project, you should keep this. All these characteristics are fulfilled by your project. You should keep in mind. All these criteria or characteristics fit. Last one is interoperable. Interoperable communication protocols. Interoperable communication protocols. This more or less we have seen in the previous class. Yes or no? We are seeing the definition. Interoperable. Now these two pillars are connected A Wi-Fi router is there. All these computers are connected to a Wi-Fi router. Here we are using the Wi-Fi protocol. But at the other place, at the far away distance, a person wants to see whether my computers are in on position or off status, on or off status. Now he may use Bluetooth connectivity. Right. So these computers are connected to the internet. They are using the broadband. We are using the broadband here. The person who is accessing this information on the other side of the cloud, he is using 5G, 4G. Protocol here is different. Protocols here are different. But still, they should be able to communicate. They still should be able to communicate. One more example I can give. Your heart rate is being measured by an Apple Watch. But your family doctor is monitoring your heart rate using a Samsung mobile phone. Platforms are different. One is Android, another one is iOS. Platforms are different. But still your devices should be able to communicate. Inter means between two operable to work out, to perform the necessary operation. Interoperable communication protocols. So these are how many? 1, 2, 3, 4, 5. 5 important characteristics of IoT. Internet of Things. Clear? Yeah. I will erase this, then we will move to the next topic. Next topic is physical design of IoT. Physical design. What is this design? One by one. Yes, madam. What is your name? Bhuvaneshwari, tell me.
Blueprint.
Blueprint. Okay, very good. Then what is template?
Just by modifying some things.
Okay, good. What do you mean by design? Where is Vikram? Today absent? Who was in other class? Because C3, C4, C3 is right? Prototype. See, everywhere it is commonly used. Designing processor, designing a building, designing a car. This is the most common word. Any answers? CR Shiva. Design algorithm. What exactly you are doing? Design means what?
gives answer to the problem.
Give answer to the problems.
How to implement.
How to implement. Right. So design is, you keep in mind, in from today onwards. What you need, how much you need, how you are arranging or mixing. In order to get your desired according to the thing, you devise your desired entity. Now you think, did I put in the design the right code or not? What are I need? How much I need? How I am going to arrange them? Or how I am going to mix them? Yes or no? See, basically we also have another two words. Analysis and synthesis. In the analysis what happens? System is given. In the analysis, a system is given to you. Give inputs, check outputs. It is analysis. What is synthesis? Input given, output given. Yes or no? Input given, output given. This synthesis. So basically in design what we do is, we first understand what we need, how much they need, and how we are going to arrange them or how we are going to mix it. This all we will see in the design aspect. Why we are doing? Why we are adjusting all this? To get my desired. Now problem. You have found out a problem. You have found out a solution. There is a problem, there is a solution. Now in between, you have to design the system. You have to design the system to get the desired solution. To get the solutions are not unique. Again, solutions are not unique. Solutions are many. So design accordingly. Design accordingly. So what we do in the design? Reduce the resources RESOURCES as much as possible. Yes or no? That will keep in mind, yes or no? You want to reduce the whole aspect is that only. You have to reduce the usage of resources as less as possible. That will be the best solution. Clear? Right. So now why I am telling is, now here physical design. Physical design. Physical here means hardware. When you start designing an IoT system for a particular solution, There's a problem, there's a particular solution. Now I want to design a IoT system. Physical here means hardware. Now you have to decide which hardware you have to use, how much you have to use, how many you have to use, how you have to arrange them. Clear? Right. Now I want involvement from you people. Now you start telling me what hardware you need. What is the hardware you need? First and foremost, what you need? See, use the experience of previous classes.
Microcontroller.
Yes, very super. The first place you need microprocessor or very good, super. Right. So that's why I bought you this hardware. What all I need? How much I need? What is the speed? How much is the capacity of the processor or processing speed? Memory storage size? What are the things I need? This is a Raspberry Pi board. Is it visible there? This is a Raspberry Pi board. Right. You can browse it in the internet. See, basically this board is available ready-made. Now imagine that this is not available. You have to start from the scratch. See, basically, right, what happens? It is not feasible. If you start from the scratch, there will be limitations of various technology. It is time consuming. I have to design from the scratch. I have to choose a processor. I have to make PCB, printed circuit board. What are the hardwares I have to choose? I have to fix on this board. Imagine in that way only. Right. So now you will help me. If I involve you, you will learn. Now you will help me. What are I require in physical design? In processor, I require CPU. Fine.
Memory.
Okay. See, now the problem that I am going to face, the solution that I am going to provide. Say it involves some images, videos. Then what I need? Use my clue. Right. See, in my applications there are some good video games. GPUs, very good. For graphics, I will use a GPU. My hardware requirement. What all I want? What all I need? Are you getting me? Later I think how much also I need them. How much service? Based on those measurement units. Then at the next place what we need? Somebody else write at that point of time. After this, storage. Before that, if I ask you, I need what is it? Storage. Yes, I require storage. No doubt. For storage, I may use a hard disk. If my device is very small, I will use a secure digital card. Right, secure digital input-output card, multimedia digital card. These are types, right? See, IoT are remote applications. Basically, I mean high, but it is right. See here, SD card slot is available. SD card slot is available. See, when I am using my IoT systems, right, in forest, in accident detection system, the whole big computer I cannot carry, right? I have constrained resources. I need my systems as small as possible. less power consuming, less processing speed, less memory. In the sense like how much I require, I want to minimize it. Design. What all I need, how much I need. Right. Then again storage also need. Before storage also I need memory interfaces. Memory interface. See, remember I am using the word interface. At the next place I will come. Interface in the sense that provision. That provision should be there. See, what is the basic meaning of interface? Interface. Interoperativity is interface between two. Between what is the meaning? Interface means two devices are exchanging the information. Two devices are exchanging the, right? For example, a keyboard, a CPU. They are sharing the information. Between two places, they are sharing the information. That is, communication is happening. In this microprocessor environment, in this computer environment, we are not just connecting. There are no just electrical signals flowing. Actually, they are exchanging the information. They are exchanging the information. Generally, in microprocessor and microcontroller lab, right, in embedded system domain, we generally use interface a keyboard with a microcontroller or a microprocessor, interface a digital display or interface a LED display, LCD display to a microprocessor. Why we are using the word interface? It is not just the electrical signals, that is voltage and current signals that they are flowing. They are actually exchanging the data, exchanging the information. We also need to write a supplement program for this. Program plus connection. Connection means hardware connection, program means software. For you people, there is no microcontroller microprocessor lab, right?
Yes.
Yes, have you come across it or not? Was there a subject? No. But as a like in computer organization architecture, have come across interfacing. Yes or no?
Yes.
See, nowadays, basically when you connect a pen drive to your laptop, it is not merely connection. The auto configuration is happening there. Auto configuration means the necessary software is happening automatically. Are you getting me? Whenever you connect a keyboard or a mouse, the background software arrangement is going on. See, earlier once upon a time when you are using a desktop system, but you remember the display, there are a lot of lights coming on the display. You say the driver is missing, driver is not working. What is the driver? Are you getting me? That is the software program. Is this idea clear?
Yes.
So in this interface is happening. So now memory interface. So for memory interface, in the sense I have a processor here. The processor I have chosen, graphics card I have chosen. Right. So in the hardware, I should have an interface for, means I should have a provision to connect to the memories. Which memories? If it is ROM, NAND or NOR based ROM. If it is RAM, it could be DDR1, DDR2, right? DDR dynamic data rate, random access memory, etc. also. This is the hardware you require. First, what are you required? Check. At the second place, how much? Are you getting the idea?
Yes, sir.
No. Done. You tell me what are you required? Rough. Yes. What are you required?
16-bit micro.
Sensors.
Sensors. Very good. Right. To sensors, what are required? General purpose input output interface. General purpose input output pins. For our laptop, these are not available. See, I said that tubelet we are connecting. Where we are connecting the tubelet? So we require. See, here it is. These are general purpose input output pins. Is it coming on this video? These. The pins that are visible at the bottom, these are general purpose input output pins. To this I will connect the tubelets. I will connect the tubelets. Yesterday in the other class I have explained it, what are sensors and what are actuators. In the other class, sensor, actuator. Sensors are one which converts a physical quantity into electrical signal. Either it could be voltage or it could be current. What does actuator I said? An electrical energy or electrical signal is converted into any physical quantity or work. Here I have given an example of a temperature sensor. Here I can give the example of your fan. Maybe I am moving at a more speed. Yesterday I have discussed it in the other class. If I want to detect the ambient light, I need to use the LDR sensor. Again, that is sensor discussion here. Okay. So let us see temperature sensor. Right. So what is it? Temperature sensor sense the temperature. What does the actuator? Fan. Switch off the switch on. Let us take the example of the air conditioner. I have set it to 19 degrees Celsius. The temperature sensor will detect. Will bring down the temperature to 90 degrees Celsius in the room. Once the temperature is 90 degrees Celsius, then here the compressor fan will go switch off. Have you observed the AC air conditioner working? Now suppose again the temperature goes about 20-21 degrees Celsius. Suddenly the noise starts. We need to start from outside. The fan will start. The compressor will start. Compressor basically fan compressor. These are actuators. Why? Because these are converting the electrical energy into some physical work. They are converting into some physical work. Are you getting? Is this projector a sensor or actuator? It is an actuator. See, in your mobile phone, whenever you keep while talking, you will touch it to the ear. The screen goes up. Which sensor? Very good. Who gave the answer? Proximity sensor. Means some physical thing is getting into electrical signal and is being given to the processor. Right. What does this sensor is doing? Say sensor is like this. In the environment, say there is a temperature. This temperature sensor is detecting this temperature. Temperature is a physical quantity. Yes or no? Convert it into electrical signals and give it to the processor. I have a LDR sensor which detects the presence of the light. LDR. If the light is very less, this LDR will convert whatever the light, physical quantity light is there, that light, it converts it into electrical signal. More the brightness, more the intensity of the light, more the electrical signal. I will decide the cutoff. If it is completely dark, the LDR sends the proportional signal. The processor will take the action. What type of action? It will switch on the tube light. There is a tube light. Switch on the tube light. Okay, I think now you are sitting in the context of sensors and actuators. Why this topic has come? Those sensors and actuators I connected to these GPIO pins, general purpose input output pins. Input pins for sensors, output pins for actuators. General purpose. Right. So and these pins need certain kind of interfaces, certain rules. Right. So interface I will also approximate it to protocols without any doubt. These are basically rules to communicate. In the previous class, people said the rules to communicate. Cut it.
Fourth type. Actually, it's fourth type.
I think that won't appear in the recording. I think the recording is the camera thing, and that is on the mobile screen. Yeah, mobiles are smart enough. The program is in such a way that yeah, that's well. No, okay. So, what are the kind of interfaces I require to? What kind of interface to connect these sensors and actuators? There are four. UART interface I require. Universal pass interface receiver transmitter. This interface, this kind of interface I require to connect a sensor or a actuator. I may use serial peripheral interface. Depending upon the context, which is best? I can use I2C, inter-integrated circuit. At some sources they call it as a protocol, at some sources they call it as an interface. But let us stick to basics, rules to communicate. Is this idea clear? SPI is there, UIT is there, I2C, CAN is also there. Controller area. Again, what I require? What I require is audio video interface. Audio video interface. Because there will be some applications. See what is our camera? Is camera a sensor or actuator? Can you tell me? Stick to basics. Our camera is a sensor or an actuator?
Sensor.
If it is confusing, you think it is an input device or an output device? Input device. Input device means what? It has to give some information to the processor. How the processor accepts the information? Electrical signals. Are you following me? Means the output of the camera should be electrical signal. Input is what? Light. The reflected light from us. Are you getting me? So camera is a sensor. I think you have come across this many times. Camera sensor, camera sensor. You should be clear. Right. Audio video interface. So what should I have? I should have some HDMI cables. Interface. I should have some RCA interface. I should have some USB. Hey, see, what I am saying is, in the design, it is not necessary I require all these things. I am collecting them. What you have to decide? What are I need? How much I need? How I have to arrange them? Keeping in mind usage of resources as less as possible. Right. So video, audio, your RJ, sorry, 3.5 mm audio jack. Now I appreciate everyone. Last one, what is missing? What I require, which is the most Clue I will give is we are in Internet of Things.
Connectivity.
Very good. Connectivity. We should have connectivity. It could be even Ethernet. It could be wireless Bluetooth. Right. Sorry, I am directly speaking to the internet. It could be USB, whatever, etc., etc. Connectivity. Fundamentally, deciding which are I need, how much I need, I am designing, I am choosing right from the scrap. Don't get confused. This is a ready-made job. This is a ready-made. See, when you go for developing the high-end applications, when you go for developing the high-end applications, imagine that you are in future you are a ISRO scientist. In future you are a DRDO scientist. You are developing a IoT project. You are building an application. Then you have to do it from the scratch. You have to choose your own PCB, your own processor, how many kind of interfaces that you should need. See here, Ethernet is available. This is RJ45, radio jockey 45, right? USB, we have USBs. I connect mouse, keyboard, any input devices, right? I also have SD card slot. I have a camera interface here. Right. So later you can browse and you can study about this. I think you have understood the essence. Why we are using why we are calling it as a physical design. Is this idea clear? Yes. Right. So in physical design, what we are going to see, what I said? Right. In physical design of IoT, we will be seeing what is the thinking IoT. Then we are seeing, right, this diagram. This what you call it. Till now we have seen the hardware requirement. Then we will be seeing IoT protocols. Right. So what we will see? We will see a thing in IoT. By this we will enter class. What is a thing in IoT? Right. When disturbance is coming, time is over, time is over. What time is over? Many people are saying 2026 Earth is going to, what is it? That time has come. That's what I am asking. No, people, somebody said, crores of people started believing it. In 2026, what is the exact word or phrase I am not understanding? Earth, Prithvi, Dashtam, what is it? Complete destruction of the earth. Then somebody asked me, really? Then I asked him, whatever property you have, you give it to me. Right. You are so believing so hard, you are believing, right? You are completely believing it, give your property to me. Right. So what is the thing in IoT? What is the thing in IoT? Internet of thing, Internet of thing, Internet of thing. What is the thing? Again and again you are hearing the word thing. What is this thing? How are you going to call this? See, till now, Dolendra, see here. Till now we have understood that this. What is this? That is disturbing me. That Earth is going to get destroyed in 2026. Yes, I am taking seriously so that I am forwarding with a projector. Till like now you have understood, we are going to call it as an embedded system. Yes or no? Yes. You are clear? You are able to understand? I am going to call it as an Internet of Things when if it is connected to the Internet. Yes. But still one thing is clear, when are you going to call it as a thing? Yes, it is connected to the Internet. Done? Connected to the Internet. Any functional part? Connecting to the Internet, is that enough? Is it It has to do any functions?
Yes.
It has to do function. What function it has to do? Okay, so there are two criteria. To call a thing in introducing thing relational, it should have first criteria unique identity. It should have unique identity. First criteria. Second criteria is it should do either sensing, it should do sensing, and or actuating. Alright, fully sensing, actuating, and or monitoring. Here also and. You understand and logic? This is the definition of a thing I am giving in a mathematical form. In a relational form. It's first of all it should have a unique identity. And means you understand logical and sensing and or actuating means it could be doing sensing also, actuating also, or sensing only. And or monitoring. Then I am going to call that as a thing in IoT. Thing in IoT. Is this study clear? Yes. Okay. So by this time, happy news for you. I am ending the class. Right.